Okay, hello students. In the previous video we learned a very important part like how to overcome the general steps of thinking, right? I don't want to make 1 1 1, I don't want to make 2 zeros in a particular row or column. So we understand a very important part, make 2 zeros in any way in the whole determinant and then you do your job, right? But if you come across any question which is already starting from 1 1 1, then you have to follow those steps. Make 2 zeros, then you expand, simplify, expand, right? So since I have told you that don't follow to make 1 1 1, make 2 zeros anywhere in the whole determinant, that doesn't mean you start solving every question that way. No, please follow the protocols. If at the end you fail to use those things, then you go for that. Is actually a backup thing, okay? Don't use the backup initially only. Okay, so let's do a question, one more question. The question is again type 1, prove that determinant is equals to 1 plus pxyz into x minus y, y minus z, z minus x. Now the elements inside the determinant I am reading it, x square 1 plus px cube, y square 1 plus py cube, z square 1 plus pz cube. Okay, so I am starting with LHS, I am writing the whole LHS here. Now see, here we come across a particular column which has something plus something, something plus something plus something plus something. So we have studied in the properties, in the last property I have told you, if any row and column is written in plus plus form, we can segregate them, right? So we can segregate this determinant into two different parts. See, x, y, z, x square, y square, z square, x square, y square, z square, 1, 1, 1, 1, 1. We have plus plus plus, we are writing plus a. Again, one more determinant, x, y, z, these two things, then px square, px, and cube, pz. Whenever you face this type of sum, where any one column, any one row has 1 plus something, 1 plus something, or something plus something, something plus something, something plus something, you are breaking this into two determinants, right? Now, in most of the sums, these two determinants will become same. They will look same. If they are not looking same directly, you have to take out something common. They will start making look same. Okay. So for the time being, they are different. So I am taking LHS as del 1 plus del 2. I am naming this determinant as del 1. I am naming this determinant as del 2. Okay. So I can see del 2, x is coming out common, y is coming out common, z is coming out common, p is coming out common. So I start working with del 2. Okay, because these two will become same after some time. In del 2, I can see p is coming out common from C3, so I am taking out common P3, p from C3. That means C1 and C2 will remain same. I am writing C1 here and C2 remain same. Only from C3, p is coming out common. So what I left with x cube, y cube, z cube. Okay, p is coming out common. Now, R1 I can take x, see x common, R2, y common, R3, z common. So I am taking out those things, taking common x from R1, y from R2, z from R3. So outside I will get p was I was already having the p. I was taking out common x, y, z. So I am writing x, y, z here. So what we left with in R1, 1 in the place of I have taken out x from R1. We left with 1. We left with x whole cube. We left with x square because we have taken x outside. We have taken y outside. 1 in the place of y square. We will have y cube, y square. Here z coming out common. So 1 z square. Okay. Now see nicely, the thing what I got here. This is what del 2, right? But see this one and see the del 1. Here in del 1, third column has 1 1 1. Here the first column has 1 1 1. The first column has x y z. Here the second column has x y z. Here the second column has x square, y square, z square. Here the third column. What I mean to say is that if I see the column wise they are same. Here also in del 1 also in one column we have 1 1 1. Here also in one column we have 1 1 1. Any one column, okay. Here also in any one column. You understand how to observe. Okay, you have to check rows and columns. Okay, here in any one row, 1x x square. Here also we have 1x x square. Okay, understood? So now see, here the third column has 1 1 1. Here the first column has 1 1. To make them look equal, I have to shift this first column element in the third column element. So what I am doing? Shifting. I am using the property interchanging. C1 interchanges to C3. That means what I mean to say, I am changing C1 and C3. C2 will remain same. Keep it like this, C2. Now what I am doing, in the place of C1 I am writing C3. See, now C1, yes, this is C1. I am writing the elements of C3. And in the place of C3, I am writing the elements of C1. Now these two matches, see. Del 1 also has C3 all 1 on 1. And here also we have 1 on 1. Okay, but again, C2 and C1 not matching. Again, in the place of C1, we should have C2. In the place of C2, we will have C1. Then these two becomes equal, these two things. Okay, these two determinant. Again, we have to interchange. Now, one more thing. When we interchange, we put a minus sign. That is the property. We put a minus sign also. So, we put a minus sign here. Rest everything remains same. Okay, C2 remains same. Only I am interchanging the C2 and C3. That means here to here. Now, I have to interchange these two. So, I am interchanging C1, interchanging to C2. Again, we have to put a one more minus sign. So we already have minus 1. Again minus 1 because minus 1 whole square. Pxyz, pxyz. Okay, C1, C3 will remain same because I am changing C1 and C2. I am interchanging them. That means what? In the place of C2 I will write C1. Whole thing I am shifting it this side and this whole thing I am shifting it this side. Now, see, check out this and the del 1. They become same. So what I got? What we are solving? We are solving del 2. We are solving del 2. That means del 2 will be equals to, because plus pxyz into, this is what, del 1. Okay, so I have converted del 2 into del 1. Now, we were working with LHS. What was LHS? Del 1 plus del 2. So in the place of del 1 I am writing del 1 only. Plus, what is del 2? Pxyz del 1. Okay, so whenever you are breaking a particular determinant into half, most of the question they become equal. Okay, most of the question, not all the questions. Huh? Now, why we were trying to make them equal? Because so we can take a common, see. Now we can get del 1 common. What is left with 1 plus p. Here we left with 1. देखो एक टर्म आ गया RHS का. Okay. So now we have to solve the del 1. Now I'm taking separately the del 1 determinant here. Okay. Understood what I'm saying? So what we need to prove? We need to prove LHS equals to RHS. So we started solving LHS. We try to break it. We got two different determinants. Out of this two determinant, one we can make it equal to other one. Okay, so first time they look different, so I am naming it as del 1 and del 2. I can see from del 2 many things are coming out common, so we started taking out common, then we interchange the columns and we got that they becomes equal with the extra term. Then I substituted LHS. This is the LHS we got. Okay, now we have to make LHS is equals to RHS. So LHS we have del 1. So what I am doing, I am not solving directly this thing the whole thing. Again. Why? See, it's type of a laborer's job. Huh? If I start solving LHS like this, del 1 into 1 plus pxyz. So 1 plus pxyz, again and again I have to write, and then I have to work with determinant again and again. Again and again we have to write 1 plus pxyz. So what I am doing, I am keeping it here only. Let's start only with del 1. So I am start only working with del 1. So this is just, I can say we are human beings, we are a little bit lethargic, little bit आलसी है ना हम लोग. So हम ये क्या कर रहा हूँ, पूरे को बार-बार नहीं लिख रहा. Okay, I am only working with del 1. You understand why I am only working with del 1? I don't want to write this 1 plus px into y into z again and again in each and every step. No, I don't want to. Okay, so that's the job only I am dealing with del 1. So let's deal with del 1. What is del 1? This was del 1. I am writing here. Okay, now this determinant is already in 1 1 1 form. बल्ले दो बार तीन बार तो 1 1 है. What I have to do? Fix 1, subtract the 2. So R2 minus R1, R3 minus R1. Okay, so what I am doing, I am changing R2 and R3. Okay, I am not doing anything with the R1. So first I am writing the R1 here only. Same, x square 1, x square 1. Now R2 minus R1, y minus x, y square minus x square, y minus 1, 0. Next R3 minus R1, z minus x, z square minus x square, y minus 1, 0. Okay. After making two zeros, what we do? We try to take out common terms. If direct common is not possible, then what we do? We try to apply formulas. So can you see direct common here? Y minus x, y square minus x square, z minus x, z square. So we can see if you apply the formula, we can take out common. So what we do? We try to apply the formula. A square and b square, a minus b, a plus b. Rest everything remains same. ये पूरा column same रहेगा, ये पूरा column same रहेगा, ये element same रहेगा. हम क्या कर रहे हैं? I'm only applying the formulas here. So that if we try to apply the formula, now check out the R2. We can take out y minus x outside. Y minus x, y minus x. From 0, anything can come out. Z minus x, Z minus x. Now, taking common y minus x from R2, Z minus x from R3. Okay, that means R1 will remain same. So what I am bringing y minus x outside. So what I left with here 1, y plus x 0. Again z minus x outside 1. Okay, z plus x left with z plus x 0. Done. We have taken out. We made 2 zeros. We taken out common. Now we have to try to expand. We try to expand using that one, that column which has 2 zeros. Here the C3 has 2 zeros. So we will expand by C3. Well, so we left with these are the 4 terms. They are small terms, fine. This into 1 is that only. So we try to expand. We don't do further simplification. Okay. So why we are not doing any simplification further? Because they are already small terms. So expand plus 1, hide these 4 terms we left with. This 0 will remain 0, this 0 will remain 0. Okay. When you expand, then you got del 1 this. Okay. Now we were working with LHS. What was LHS? This was LHS. So in the place of del 1, sorry, not this one. This was the LHS, right? So in the place of del 1, we substitute the value into 1 plus pxyz. Now check out the LHS and the RHS. 1 plus pxyz, 1 plus pxyz we got. In the place of x minus y, what I got? Opposite. Z minus x. In the place of y minus z, we got opposite. So 2 terms opposite. Fine. 2 terms opposite, take a minus from here. Minus 1 from here. Minus 2 to minus 1 become positive. And we have written the whole thing again. Just reverse the thing. Okay. Thank you, class.